Hello students. In the last class you studied attenuation. Attenuation is a loss of power suffered by the optical signal as it propagates through optical fiber. Now we will derive an expression for attenuation coefficient by using Lambert's law. According to Lambert's law, the rate of decrease in the intensity of light with the distance travelled in a homogeneous medium is directly proportional to initial intensity. It is given by that this equation where P is initial intensity and L is the distance propagated in the medium, where negative sign indicates the decrement. Remove this proportionality, we get minus dP by dL is equal to alpha P, where alpha is a constant called attenuation coefficient or simply attenuation. It is different for different media. Rearrange equation 3.27. We get dP by P is equal to minus alpha dL. By integrating both sides, we get integral of dP by P is equal to minus alpha integral of dL. If P in is input power and P out is output power, these two are limits taken for power and L is length of the optical fiber. Then by applying these limits, we get integral of dP by P is equal to minus alpha integral of dL. Integrating this equation, we get this equation because integral of 1 by P is a ln P and integral of dL is a L. So ln P is equal to minus alpha L. Apply that limit, we get ln P out by P in, that is equal to minus alpha L, or alpha is equal to minus 1 by L ln P out by P in. In optical fiber communication, we write this equation in the form of log to the base 10. That means natural log is written as log to the base 10. That is alpha is equal to minus 1 by L log to the base 10 P out by P in. Unit is bell per unit length. If length is expressed in kilometer, then we can write attenuation coefficient alpha is equal to minus 10 by L log to the base 10 P out by P in decibel per kilometer, where P in and P out are expressed in watt. This is the expression for attenuation coefficient. Now we'll see application of optical fiber. One of that application is basics of point-to-point communication using optical fibers. Point-to-point communication is the transmission of information from one point to another point by using optical fibers. This system has got two parts, transmitter section and receiver section. Transmitter section contains a transducer, amplifier, modulator, laser, diode, and receiver section consists photo, detector, amplifier, and demodulator. And this is that optical fiber. It has got core, cladding. Consider voice of a person. It is in the form of sound wave, that is a non-electrical signal. It is fed to transducer. Transducer converts sound waves to electrical signals. These electrical signals are amplified by using amplifier. Amplified electrical signals are modulated by using modulator. Again, modulated electrical signals are fed to laser diode, which converts electrical signals to optical signals. These optical signals are made to pass through optical fiber. There, these signals undergo total internal reflection. In the output section, optical signals are received by photodetector. Photodetector is an electronic device which converts optical signals to electrical signals. These electrical signals are amplified by using amplifier again. Amplified electrical signals are demodulated. and in the receiving section, receiver converts electrical signals to sound waves. So this is about point to point communication system using optical fibers. Some other applications of optical fibers we can see. Optical fibers are used in medical field to visually examine the inner part of the human body. This technique is known as endoscopy. Similarly, in high-tech buildings, optical fibers are used to bring sunlight from the roof to the other parts of the building. These optical fibers are used in spectroscopy. For example, optical fiber cables are used to transmit light from the spectrometer to substance which cannot be placed inside the spectrometer in order to analyze its composition. Now we'll see advantages of optical fiber communication or merits of optical fiber communication. Optical fibers are cheaper because they are made from silica and plastic, both of which are easily available. Because of their compactness and lightweightness, fibers are much easier to transport. The communication system is not affected by electromagnetic disturbances, especially during thunderstorms. Quality of communication is better as the transmission losses are low. There is no crosstalk in telecommunication. Signals traveling in one cable to cable do not give rise to induced signal in nearby cables. They are not affected by corrosion. Now we'll see demerits of optical fiber communication. Splicing is a skillful task. Splicing means joining two optical fibers. Since the optic connectors which are used to connect two fibers are highly expensive. Operations required to re-establish the connections are highly skillful and time consuming. Fibers may break when bent to small curvature, so there exists a loss of a signal. While fibers undergo expansion and contraction with the temperature, light rays fails to undergo total internal reflection and it is considered as a loss. So this is about optical